We're going to go over the graphs then of the 6 trigonometric functions. So first we're going to do sine theta. And we're going to think about going for 1 trip around the unit circle, or 2 pi. So that's the period for the sine function is 2 pi, and it repeats every 2 pi, so it keeps going. Even though I'm only going to graph maybe 1 period, it does keep going and going. I'll try to show that. All right, so cut that in half and make that pi. Cut that in half, make it pi over 2. Notice that we don't use degree measurements on this. That's for a good reason. Because a degree measurement has to do with being on a circle, and we're trying to graph this in a Cartesian coordinate system. We need lengths. So that's why that's the case, in case you were wondering. Okay, so now we want to think about the sine of these different angles. We're going to start at 0, and the sine of 0 is going to be 0. And then we're going to be going up to 1 and down to -1. Just eyeballing these. That's the range, -1 to 1 for sine is -1 to 1, that's the range. Okay, so we're going up to 1/2. That's got a sine of pi over 2 is 1, and then sine of pi is 0. Think about going around the unit circle at 90 degrees, you're at pi over 2, and then at 180 you're at pi, so on and so forth. And then 3 pi over 2, you're down at -1, and at 2 pi you're back, you've completed the circle. And it looks something like that. Now, if you were to keep going, and you were to say, okay, well now here I am at the next, let's see, what would that be? 5 pi over 2. And then you were to go, keep going, and then here, that'd be 3 pi. And then you'd repeat the cycle. So it'd be up here at 1, and then back down here at 0, and it would keep going. And I'm going to run out of room, but you'd have the next one, which would be, let's see, if I add pi over 2, what's that? 7 pi over 2. Now I'm really out of room. And that's going to be down there at -1. And it keeps continuing. And you've seen waves like that maybe in science classes and so forth. You can also go in the other direction. So if I mark off negative pi over 2, and then I'm going down here to -1, and then negative pi, a little bit harder for me to see this way, but, and then negative 3 pi over 2. And so you're going down and up and up. So it's going to go, and it continues on in that direction as well. Okay, so sometimes they'll just ask you to graph over 1 period or 2 periods or something like that. But that's the sine curve then and what it looks like. Let's go to the cosine curve. And cosine theta. Period for cosine is also 2 pi, so I'm just going to mark this off. I probably won't do more than 1 period on this one. And then cut that in half, make it pi. Cut it in half, pi over 2. And then cut this in half, that's 3 pi over 2. Those are all the quadrantal angles that you have. And so you have to remember what they are, but the range is still -1 to 1. And so the cosine of 0 was 1. And so we start up here, and then it comes down to cosine of pi over 2 is 0. Cosine of pi is -1. And then we're going back up. We'll go to pi over 2. And we're back at 1. And so it curves like this. It should really look like the sine curve, only it's just shifted, okay? And it keeps going as well. You can keep going, in both directions, but it keeps going. Keeps going. Sometimes I'll do this little thing. Anyway, it looks better usually. Okay. So that's sine and cosine. I'll go ahead and keep going and see if I can get all these on one video. And so our next one's going to be tangent. theta? Tangent has a different period. The period is pi. And so what we do is we straddle it. We go pi over 2 and negative pi over 2. And then every pi, unit of pi, is going to be another period. So we could do that. Let me do this first of all. At pi over 2, it's undefined. And at negative pi over 2, it's undefined. And then the tangent of 0 is 0. Now, in this case, we often will graph pi over 4, which is a 45-degree angle, pi over 4, and that's 1. So we do that because it's fairly easy to graph it. And then if you were to go in the other direction, in the fourth quadrant, you'd get negative 1. And so you get this curve. The range is from negative infinity to infinity. And it looks something like that. And then if you wanted to repeat it, you could go another pi over 2. So this would be pi here. And then another one, which would be 3 pi over 2. And this is where your asymptote would be. So we have these asymptotes because it's undefined. And then you'd have, like a point in here and a point in here. And it would look just like the first one, if I could draw. And then that repeats as well. And it's going to be, you just keep adding pi as it's going to give you another period. Okay, let's go to cotangent then. So the cotangent theta, oops. Cotangent theta. And then this one starts out with, at 0, you're going to have an asymptote. So you could go back and check this on your chart, what we did earlier with the quadrantal angles. And then the period for cotangent is also pi. So just go pi. And that's going to give you another asymptote then at pi. And you could, you can do more than one period as well. So here you are at pi over 2. And then, let's see, we have to think. So at pi over 2, you have, it's going to be 0. The cotangent of pi over 2 is going to be 0. And then think about what quadrant you're in. At pi over 4, you're in quadrant 1, right? And so the cotangent should be positive. So if I say here's 1 and here's negative 1, so it's going to be like right there. Now, if I were to be halfway between pi over 2 and pi, I would be in the second quadrant, and the cotangent is going to be negative in that quadrant. And so we're expecting it to be down here. So you'll notice that it kind of changed its tune. It's going in the other direction. And then you could repeat that for every pi, you'd get another period. Okay, let's go on. This will be a long video. And we'll do, let's see, what do we need to do? Let's start with cosecant. And the cosecant of theta, so we have to think about, well, when sine was 0, or the sine of 0 was 0, right? So the reciprocal is undefined. And so you're going to get an asymptote here. So replace the sine was 0 is now going to be an asymptote on the cosecant curve. So it does have a period of 2 pi. Let's mark off 2 pi. Let's mark off pi. Pi over 2. And 3 pi over 2. And so if you remember on the sine curve, pi was 0, so that's going to be an asymptote. Pi over 2 is 0, that's going to be an asymptote. Something like that. Okay. And then think about when was it 1? Well, it was 1 at pi over 2, and we're probably going to need a negative 1 in here as well, so put that in. And so the reciprocal of 1 is 1. But the thing is now these cosecant curve is going to go up towards these asymptotes. Now you could put in more angle measurements, in radians and get more values to graph if you wanted to, or you could use a graphing calculator to graph this. And then at 3 pi over 2, so think about going down where the point, it's a quadrantal angle, and the point is 0, negative 1. The reciprocal of negative 1 is going to be negative 1, and so you're going to get it to go this way. And again, this is going to repeat also every 2 pi. You're going to keep having these asymptotes and these parts of the cosecant curve. All right, so I think we've got one more to do. I'm running out of time, but that's okay. And it's going to be the secant curve. And so we think about the secant curve. It's going to have a period of 2 pi. And I'm just going to choose to do it this way. And there's pi, pi over 2, 3 pi over 2. Okay, and when was, now secant's the reciprocal of cosine, so when was cosine 0? Well, cosine was 0 at pi over 2. So that's going to be an asymptote there. And then at 3 pi over 2, you're also going to get an asymptote there. Okay, now, what was, at 0 degrees, what was the cosine? 1. Let's see, 1. And so the reciprocal is going to be 1, and it's going to go up this way. Now, if you're saying, well, that doesn't look very good, I don't like that, you could go over here to negative pi over 2, make your asymptote, and then get the rest of that to go, to go in there. So you could do that. And then at pi, it's going to be negative 1. The reciprocal of the cosine is negative 1. The reciprocal is going to be negative 1 for secant. And it's going to go this way. And then you can see at 2 pi, you're back to 0, and so it's going to go this way. And you could keep going. You could add, more asymptotes and graph more because it's cyclical, and it's going to keep going. All right, those are the graphs. You should be familiar with them, but, don't worry if you don't get everything. So.